Find the set of values of k for which the line y equals 2x plus k intersects the curve y equals 3x squared plus 12x plus 13 at two distinct points. So this straight line is intersecting this curve. So intersecting, key word there, makes me think simultaneous equations, which means that I could substitute this in instead of the y here. So let me do that. I'm going to say 2x plus k is equal to 3x squared plus 12x plus 13. Right, let's rearrange this. So I'm going to take the 2x away from both sides. And I'm going to take the k away from both sides. Now, obviously I can't solve this equation because I don't know what k is. But I don't need to solve it because what I'm interested in is the values of k here that mean that this equation has two different solutions. So when does this equation have two different solutions? Well, that's going to be when the discriminant is positive. So in this equation, my a is 3, my b is 10, my c is 13 minus k. Right, so let's substitute those into the discriminant. So b squared minus 4 times 3 times, use brackets here, 13 minus k, then that has to be greater than 0. 10 squared is 100, 4 times 3 is 12. Let's expand those brackets. So 12 times 13 is 156. Then we've got the minus 12 times the minus k. So that's plus 12k. The 100 minus the 156 is minus 56. Let's add 56 to both sides and divide both sides by 12. So k has to be greater than 56 over 12, or k is greater. Let's simplify the fraction to be 14 over 3. If k is bigger than 14 over 3, then this straight line will intersect that quadratic in two places. Part I. Express 3x squared plus 12x plus 13 in the form a bracket x plus b all squared plus c. Hence, show that the curve lies completely above the x-axis. Well, this is saying to complete the square. I can't complete the square when I've got a 3 at the front, so I'm going to have to factorise that outside first. So let's do that. Let's put the 3 on the outside, so that'll leave me with an x squared here. I'll have a 4x from the 12x, and we'll keep the 13 over here. So just to clarify, we've got the 3x squared, we've got the 12x, and then we've got the 13 on the end. Right, let's complete the square. So x, that's half the 4, and take away that 2 squared. And let's expand the brackets. So we've got 3 lots of this, we have then got 3 lots of the minus 4, which is minus 12. Don't forget the plus 13. And we'll simplify that. The minus 12 plus 13 is plus 1. Right, so we have written it in this form. It now says, hence, show that this curve lies completely above the x-axis. Well, the completed the square form tells me that the minimum is at minus 2 plus 1. Minus 2 because of this and plus 1 because of this. So the minimum is at minus 2, 1. So that's saying the minimum the y coordinate can be is 1. It's basically saying that my graph, the minimum is at minus 2, 1, which is like roughly there. The x coordinate is minus 2, the y coordinate is 1. So it's looking like this. The minimum the y coordinate can be is 1. Therefore, it always has to be bigger than 1. And therefore, it always has to be positive and always above the x-axis. The y coordinate can never be down here with negative. So all I would do here to finish this, to finish part II off, is I'd just write a little sentence and say minimum y coordinate is 1, therefore always above x-axis. Right, part III. We need to find the value of k for which y equals 2x plus k passes through the minimum point of that function. We just worked out the minimum point, which was minus 2, 1. So what value of k makes this equation pass through that point? So when the y coordinate is 1, just substituting 1 in here, the x coordinate is minus 2. So k is 5. If k is 5, then y equals 2x plus 5 will pass through the minimum point. So k is 5. That's the answer. And we're done.